drones today. So I just want to give you a quick overview on what I do with them. I'm part of a project team at Cornell called CUAir. I'm part of the Cornell's project team lab, which has a bunch of project teams that do different things. My personal team builds fixed-wing unmanned aerial vehicles, or UAVs for short. So what are drones? There's a few different types of drones that you could be talking about. UAVs, which is what I do, is an unmanned aerial vehicle. Then there's also AUVs, which are autonomous underwater vehicles. And then RPAs, which are remotely piloted aircrafts. So that would be like your common RC plane, if anyone here has flown. Does anyone actually fly planes? Quadcopters or something? RC cars?
Yeah.
There we go. Yeah, so that would be the same thing, except aircraft. So this is a picture of my plane from last year. As you can see, it's not like a standard plane. It has like the long wings, and then instead of like a T-tail, where it's the rudder and then the elevators, we had a rudder vader, an inverted rudder vader, which is the combination of the two. So then, this is the lab that's next to me. This is CUAUV, and they make underwater submarines. And then this is the standard quadcopter that you'll see pretty much everywhere. So, what are they used for? The majority of drones can be used for any number of things. The main thing that everyone's starting to see now is aerial photography. Does anyone know like the DJI Phantom or stuff like that? Yeah, if you're following, this is one of the DJI Phantom. They also just came out with the DJI Inspire with a 4K camera, if anyone has money. They can be used for search and rescue, which is what our primary competition does, is we have to go and create a drone capable of surveying an area and identifying stuff on the ground. We'll talk more about my team later. And then we have to drop them relief canisters. They can be used for underwater maintenance. So that would be the AUVs, these submarines going to do work. So say like BP has a huge oil explosion underwater, like they did a few years ago. They actually just sent down drones to go fix it. AUVs to go and do all the operations to fix their pipes. To survey land, this is a very common thing that drones are used for. If you look up any of the recent TED Talks on drones, this is one of the top ones that's going to come up, is them using it for land surveying and counting the number of rhinos that are still living and checking for poachers. Military applications, this isn't the side we ever like to talk about, but they are used. Predator drones are a very big thing and a very scary thing. Fun fact, our autopilot, the one that is in my hand now, is more powerful than theirs. And then delivery. Amazon Prime, I'm sure all of you use it. They could have gotten our parts here a lot earlier. They are starting to try to roll this out if they can get permissions, is air delivery within 30 minutes of you ordering something. That's good. So what actually makes up a drone? What makes them this awesome? So who's here is doing the hovercraft? Yeah. So what you're doing could easily be replaced by this, or you could use this as a supplement for it. Basically, you're going to have 3 servo outputs. You're going to have your fan on the bottom, your fan pushing you around, and then the servo. That takes up 3 of my inputs, and then this can be doing the rest for you. If you ever want to mod it that way. So what makes them this is the body of the vehicle. This is just your RC plane, this is your car, this is your hovercraft. Whatever it is, you can just take those and plug them into an autopilot. The brain, that's physically the autopilot. This will be running the code to actually make all your things work. My code is about 50,000 lines of C++ programming. That's a lot. I only probably wrote 2,000 of that. But that's what you can do, and you can do it relatively easily now with all the open source autopilots. Actuators, those are just, does anyone know what an actuator is? It's a servo. It's something that actuates or moves the parts of your thing. So for me, that moves my ailerons up or down, that'll move my elevator rudder. that we have control over our planes. Propulsion, that's going to be your propeller, those are your turbines, those are anything that you're going to be using to move your vehicle forward. And then sensors. This thing is just a brain. There's no connection to the outside world. You need to have those sensors to be able to work. So, does anyone have any idea of what sensors we would need to get an autopilot working? You can just shout them out or raise your hand.
Ultrasonic.
What?
Ultrasonic.
Ultrasonic, for what?
Sensing distances.
Sensing distances, good. Anyone else? What? Gyroscope? Yeah. So gyroscope would give me what?
Stabilization.
Yeah. So tell us which way down is. Anyone else?
Altitude sensor.
An altitude sensor, good. Do you know what type of altitude sensor?
Pressure.
Pressure. Yeah, we use pitot tubes for that, where it'll tell you where you are in the sky based on differences in pressure, but that's also what we use for airspeed. The pitot tube we use is for airspeed, but you can also use it barometric pressure to tell your altitude. Anyone else? One of the most important ones for an autopilot is your GPS. This will tell you where you are in the sky, and you can tell it the waypoints that you're going to. Accelerometer, someone's using an accelerometer. There you are. So, all those things, we have to interface with them to be able to go and fly the plane. A ground control station, does anyone actually know what that is or what it does? So that would be used to actually interface with the autopilot. That's how we control our big plane, I guess, is by giving it waypoints to fly to, places to take off and land at, and our data link. Our data link, you don't necessarily need it for an autopilot, but if you're going to be doing anything in real time where you want to see what's going on, any troubleshooting, you're going to want a data link to this. So, is anyone here ordering XPs for their project? Yeah, that's our data link. That's what I personally use as my data link for my autopilot. We also have an RC controller, which will go transmitter to receiver to give us manual control of the plane if we ever want it. So, just a basic schematic of how a simple quadcopter will work is we have our motors running to an autopilot. Those are going to be all you actually need to control the plane, but if you want to be able to do it intelligently, you need a bunch of other stuff. So our video cable, you don't actually need that, but it's cool to have. That's why we do aerial photography and all that. Your 8-pin cable. This goes to our gimbal, and that would go also to the GPS, but I don't think they're saying it. Anyways, our gimbal is just something that'll go and turn the camera around and look everywhere. So that's very important for my team as well, because one of the tasks that we have to do for our competition is to fly over a field and survey the field trying to look for targets. So we need our camera to be able to survey the ground to do that. So 5-pin now cable compass. That is just going to tell us which way we're flying. The actual compass itself. Whatever. And then the CAN bus connector. A lot of you are going to be using different communication methods. CAN is just one of the common communication methods, such as I2C. That's another thing you might be using in SPI. I don't know if any of you are actually using it, but for something like hovercraft, that would be used for your sensors and stuff. And then this is the inside of one of our autopilots. Not this one specifically, but this is for a quadcopter. So this has our altimeter, which will give us altitude, magnometer, which will give us, we'll mix that with our accelerometer and gyroscope to give us better data. So one of the things is your sensors are going to give you good data, they're not going to give you the best data possible. So who has an iPhone, or, yeah, who has an iPhone? I want you to take out your phone, not now, but just take it and start spinning it this way. Your screen is no longer going to stay vertical. It's going to flip. At some point, your screen will flip and think it's horizontal. Does anyone know why?
Internal gyroscope?
Your internal gyroscope?
That was a wild guess.
No, it would be based on your accelerometer. The way your phone goes and tells which way it's pointing is with its accelerometer. because gravity has 9.8 G's down. So if you start spinning this way, and you get an acceleration this way, it's going to think that this way is down, and your screen is going to flip. So in order for that not to happen when my plane is turning that fast as well, you have to mix it with some other sensors. Just to get the best data possible, you have to be able to be using complementary sensors to tell you this is good data, this isn't good data. So here you can see how they put the accelerometer and the gyroscope together. That's where you'd be using that data. That's how you mix the data. The XP radio is your downlink. That will be giving you telemetry and also allow you to talk to your autopilot. Does anyone know what telemetry is? It's far away measurements. Tele is far away, metry is measurements. Your power selector, that's if you're going to be using something other than a battery to power you. So if you're doing ground testing, you might want to just plug into the wall so that you can do ground testing. Forearm interface is to connect to the 4 rotors that you're using for your quadcopter. USB is if you're programming it. And your processor. All of this requires a fairly decent processor. So, those are that. Before I go on to show you fun videos, does anyone have any questions? No? Yeah.
I mean, how did you initially find out that you needed sensors of calibration? Did it just like fall out of the sky or something?
Yes. So not us personally, although we do fall out of the sky plenty of times because we test twice a week, every week, or 2 days a week, every week. But someone's plane did fall out of the sky, and every once in a while you realize that some data is not going to be good data depending on the scenarios that you're in. So that's something that you always have to look into.
So like in certain weather conditions, you can just not look around them?
Yeah. Well, you'll still have them on your plane because most of them are going to be like weatherproof, but some of them aren't going to be good. So one of the things that always happens when we're flying is there's a certain drift in our sensors, specifically our airspeed sensor, where what it thinks is the ground point is no longer the ground point, is no longer a 0. So my thing thinks that negative 40 miles per hour is its usual speed, is the 0 speed. So when I'm flying, my plane will always tell me that I'm going at 70 miles per hour, and that's way higher than our plane is actually able to go. Our plane can fly at 30 knots, which is around 34 miles per hour, or 55 kilometers per hour. So that's just something that we know. We just turn off the airspeed sensor because we don't want it messing up the autopilot anymore. Anyone else? Alright. You want, I can start showing you some videos.
Go for it.
Yep.
I'm trying to follow the light so we can see a little bit better though.
So, where exactly is
What would you recommend if one of them wanted to start getting into drones? Is there a basic thing that they can get started with?
So what you should get started with is RC planes, or quadcopters. As soon as you start getting comfortable with an RC plane or a quadcopter, it's very easy to throw your autopilot in there and then hook up a switch to your autopilot to say, I'm going to go in auto mode now, I'm going to go in manual mode right now. So if you want, start with a card. There's a lot of very easy things out there. So if you guys want to look up the Ardu pilot, it runs off, or it originally ran off the Arduino. Now it's a lot better stuff, but it uses a lot of the software that could be compiled down to that. So that's fine. So this is my team. This is the lab that I work in. So as we're going and building the plane, we build our plane from scratch each year, but you can easily buy a kit plane for like $100 and then throw an autopilot into it the same way you would connect your servos to a receiver. you would connect your servos instead of the receiver, you're connected to the autopilot. So we have a receiver, and I can show you that in a little bit. But here is the very first time we flew our plane this year. As you can see, we have to fly in snow, but the autopilot is sophisticated enough that it can do that. It can deal with most weathers, and then although some of the sensors don't work down to that temperature, we still were able to go and like get data without our ultrasonic sensor, because our ultrasonic sensor stops working below like 40 degrees because it wasn't the best. But I'll go back. Yeah, so we do catapult launch to get our plane to the air. You can do pretty much anything you want to get your plane to the air, but this was just easiest for us to do an autonomous takeoff. So let's say in years past, we've been using a $20,000 autopilot that we had gotten from CloudCap. That was not very easy to go and get autonomous takeoff and autonomous landing working. So instead of putting something that expensive up in the air, we switched over to a new autopilot that we wouldn't really care as much if it died on us. The one, wherever it is, this only costs about $200, and you can get these on 3DR, robotics, and other things like that. Hobby King will sell them, Amazon sells them. They're very easy to get, and they're very fun. Anything else?